Okay. Should be live. Make sure this is using the right device. Oh, okay. Now the one thing I gotta do before we get started is I have to remember to cancel. It's 10:10. I gotta remember to cancel a thing. All right. I've been slacking on the monthly meets, but I've been busy doing other stuff. Well, this is interesting. So this result is about on par with what we have before. Let's add, so this is the result. No, wrong way. It should be score. Ah. Most of these have very low coefficient here. What other params did I add? Morning. Working on improved PPO? I will be for a lot of today. I'm just checking on. This is exploration method that we implemented on Saturday. I'm seeing if it did anything. Archive. Gotta get the graph for it though. What's the exploration method? It's an old paper from Sergey's group, Diversity is All You Need. The idea is to train policies that are conditioned on a little extra observation that's varied per episode. And then that observation it's supposed to be discernible from a discriminator. So basically you're trying to learn conditional policies that behave visually differently. Are you happy with Neptune over Wanby? Yeah, it's been good so far. It would look to me that this doesn't actually have much of an effect. Yeah. It's weird that this loss is so low. I mean, looking at these, right? It doesn't seem like there's much of an effect at all. Okay. So that's something to keep in mind. I'm just gonna go grab one of these for a tweet real quick. The Pokemon stuff. Breakout isn't a great test. Assume you. Yes, I just ran a sweep to see if it works at all. Basically, it doesn't crash performance, but it doesn't really seem to have much correlation at all with perf. On with Twitter. Hello? Internet's working. Is something broken with X right now? Like, yeah, it doesn't load. Huh, yeah, X just doesn't load. Okay. Guess we'll come back to that. Solve Pokemon, don't they do a lot of hacky stuff like super specific, reward shaping? Yes, but you have to keep in mind something here. We had 4 GPUs for this. So a lot of the time, these reward shaping objectives, you end up ablating out a lot of them, and you just don't have compute for that. So it's like, ironically, the bigger labs with the bigger projects often have the simpler solutions just because they have compute to run like all the experiments they want. Here, it's harder to do that. So I think that we wouldn't be able to get rid of all of them, but I think we'd be able to get rid of some of them. And also, you got to keep in mind as well, this is a huge result for RL. This is a qualitatively new type of success. It's a 25-hour game. Yeah. I mean, literally, if I'm like, if it just worked with no reward shaping, like if it just worked super cleanly with no reward shaping, like, and it was a fully general method, I would consider it to be the top result in the field. It's not, so I mean, it's harder to place now. I think if we get rid of most of the scripting, it would be like a top 5 result. SPS they get with Pieboy trains around 10K and it's bottlenecked by the end. I think it's like 6 to 10K training steps per second, depending. Mm-hmm. No, there isn't. That's the problem. 10K was with puffer optimizations. It was much slower without them. And you see that this is kind of the default in RL as well. Like most stuff in RL is slower than that. So when you say 10K is limiting, like probably 80% plus of RL projects train slower than that. Maybe it's 90 plus percent. I mean, you see papers published consistently. Like very, very often, papers will be published and the training speed will be between like 500 and 2,000 steps per second for dead simple problems. See, there you go. So it's easy to take for granted the stuff Puffer does. Oops. Easy to take for granted the stuff Puffer does, but I mean, like, literally, the field is a different field now because of Puffer, because of that speed difference. People just haven't realized it yet. Hey, sir, how are things going today? Things are going well. Little bit of a slow start to Monday, but that's fine. Clock's changed and all. 200K for some robotics M's. Yeah, that stuff is also all pretty new. Like, we were dealing with Isaac Gym code recently, where it was, I believe, around 20K with like 10,000 lines of god awful cursed wrappers and like redundant, useless stuff. So, also, it's not exactly comparable either, Noah, because if you want to get really technical here, um, it's not so much the steps per second that matters, it's the real-time amount of experience collected per second of CPU or GPU time. So if you have to run like 60 frames per second of a robotic sim, like you're not really getting more data than a game where you only have to run it one time per second. Because typically we care about the horizon on which humans look at stuff. So it's more useful to take, it is more useful to look at wall clock equivalents of samples collected. Working now and can't even access our Olama models. Jeez. That's company bloat for you. That is company bloat for you. What? Hang on. Is everything broken today? Did everybody just decide today is tech vacation? Okay. Presumably my token's expired. It's weird. Yep. Just needs a new token. Do you know if PokeRL people are looking for contributors? I mean, we kind of run the project from within Puffer. So yeah, like anybody can contribute stuff. It's the same, it runs the same way as everything else with Puffer, right? It's like if you stick around and do stuff, then that's great. I'd love to merge your card game stuff at some point though, because that was going really well. You had a really nice PR there. Now fixed. Is X working again? It is. I think after exams, I'll finish TCG, then look at Pokemon stuff. Awesome. Yeah, no, the Pokemon stuff is good. It's just, it's very heavy. It's very heavy because it's slow, right? A lot of the other stuff in Puffer is just way easier to work on because it's fast. We train up to 2.5 million steps per second now. And see, this is already, this random experiment's running over 1 million steps per second, right? Exams are no fun. Are a lot of hacks being used to get the policy to beat Pokemon? In reward space, yes. If you read the blog post, you'll get a full detail of it. There are a couple of them I really wish we didn't have. Most of them are pretty benign. But the other thing that I keep saying, right, you have to realize that when you have, if you have 10,000 GPUs, or if your experiments run as fast as the experiments that we have in Puffer, you can run full hyperparameter sweeps on every ablation that you want, and you can just get rid of most of the hacks, right? But because Pokemon is slow, we can't do that. So ironically, if you have a slower environment, you're going to have a more complicated solution, right? A lot of the rest of the stuff in Puffer is very, very clean, even though we're using the same implementation, the same everything else, just because it's easier for us to tune and iterate with what we have here. Now, my hope is that we're going to be able to build better algorithms, better general purpose tools and stuff, such that we'll be able to clean stuff like that up in Pokemon and other projects without having to run thousands of experiments. But for now, this is the state of RL. What are all the new M's we should have in the next release? Tower Climb and Impulse Wars are the two big ones. And then there's, we merged Blastar as like the little one. GPU drive, Spencer's working on. I don't know if like the timeline on that. I guess it's no longer GPU drive. Then there is It depends if Tosin finishes robocode, or if Noah gets the TCG into a state where you can actually train on it and do something, right? But the core ones that I see is like the big ones are going to be the tower climb and of course your big impulse wars M. So the bottleneck for RL is the speed at which the environments run. The bottleneck for RL is that nothing makes sense and everything is incredibly janky and nobody knows why. Because nobody's bothered to do proper science because the M's are too slow. So it's a kind of a roundabout problem. We're fixing all of it though in Puffer. The plan is quite simple, right? Make everything fast, run exhaustive experiments on everything that doesn't make sense and is janky so that we understand why it's janky and how we can fix it. Then use that to build methods that don't have those problems, and then we can run those methods on whatever we want and not have to have everything be so fiddly. That's kind of my rough plan for the year. Are you planning to work on some new exploration methods? Feel something that could clearly improve a lot of RLMs. I'm trying to see if there's anything remotely good in the current ones at the moment. My my current impression is that a lot of exploration work in RL is just very poorly motivated, and like they kind of lose at the problem definition. The way that they define stuff doesn't even really make sense. So I'm seeing if we can get anything out of exploration at all first, and then from there maybe we'll see if we can do something better. But like, I'm not going to try to make a better version of one of the existing methods if the existing methods just don't make any sense. Like, I don't think that anything noise based like R&D is a good idea. I think that all those methods are just bad, and then I think all the counts based methods are also bad. So that's like 80% of the research right there. This thing I think has a lot more potential right here, the P30 stuff. Though I'm realizing since it's really a modification to GAE, I could also go with GGAE, which would be funny. Puffer GG presents GGAE. You pass new value mean, reward block, and new value variance. Is this correct? GG. Well, I mean, the new algorithm, right? It is really a modification of generalized advantage estimation. Confused here. Mass block values, mean values, standard deviation, buff. Yeah, okay, this is all very, very confused, I think. Experience B returns. Let me see. Weird. Yeah, there we are. Ah, I see the issue. There we go. Go down to here. Okay, so now this is pointing at the correct thing, I believe. And these are some crazy values, right? Yeah. Here you're just adding up all the rewards, right? I don't know about this. I'm trying to think like what's a quick normalization I could throw on this thing. Actually, why does it end up being this much? Oh, because of the reward standard deviation, okay. Okay, this is fine. Fiddly CUDA kernel is all. Very fiddly CUDA kernel. it's still going to be ridiculously unnormalized is the problem here. We're at the breakpoint. Okay, there we go. That's something. And why did this get... That's bizarre. Yeah, that's bizarre. Yeah, there's something weird here where the first element's not getting set. Why is value standard deviation 1? Oh, this might just be a bounds thing. That's fine. I think how we normalize this. Oh, we have mask block. Then actually this is not that hard, right? So we do. Subtract the mean. I don't know how to get standard deviation, though. That's going to be a problem. I don't know what the hell is with this reshape. Alright, so that's fine. See if this thing has a keep dims. And you need to do plus 1, -8. Maybe this will be enough, we'll see. I think advantage is probably just 0 here, right? Yeah, this buffer is never more than 0. Very weird. Why is this first element always just not getting updated? That's probably what's killing it. So is 0. Now something's very weird there though. Yeah, it's capped. Yeah, that's not where the boundary should be, right? Mm-mm. K minus 2, J greater than 0, J minus minus. I'm gonna start working on getting neural net code working in C. Any tips I should know before I start? Should probably just try to get the MMO code working, and the easiest thing to do is to write an explicit test. Just explicitly test that the outputs of the PyTorch code exactly match the C code. That's what I would suggest. Like I have this test that I use for all the PyTorch layers. You just do that. You just build the same network and make sure they match exactly. Okay, at least that fixes this. Mm-mm. Okay, so this is not happy. How does this still not trigger right here? Okay, here's your value standard deviation, right? Ah, okay. So we have some negatives. Well, this is good. Why is there data at the end there? A really weird cramp. Don't know what that was. Throat just totally cramped. Okay. Your reward. Yeah, I don't know how this would be getting any data on it. I'm actually thinking it might be worth making a separate test for this. It's just a little tricky to do that because this is running through, let me see. Yeah, this is running with torch tensor here, torch extension. So I might have to fiddle with that. But I think that's what we will have to do. I'm gonna fiddle with it a little more first. Because I'd really like to be able to have a debugger here. Am I zeroing it? I thought I was, right? Yeah, I am zeroing it. K minus 2. Hang on. K equals... I mean, regardless, like... It looks like it does start the second to last one. And gamma is going to be... times this, but then it gets multiplied by r. Yeah, no. Oh, but you subtracted... Yeah, you subtracted out the mean and stuff, so that's why. That's fine then. Okay. And now you have advantages, right? Yeah, now you have advantages. Value loss all over the place. Let's see what we're trying to hit here. Value mean, turn, Yeah. Oh, this is tough. This is tough. I think I probably still have not thought enough about how to do this. Because these are going to just make crazy large coefficients, right? Yeah. Okay, well, we'll have to think more about this. Let's see, it's 11:19. I think I gotta get going. I have a doctor's appointment today, and then I'll be back in the afternoon. An error occurred. Huh, it hasn't been live on X. That's weird. All right, but I'll be back in the afternoon, so thanks, folks.